Okay, so let's go. Okay. We're starting with this one. The curve C has equation y is equal to x squared over x minus 3. Find the equations of the asymptotes of C. All right, so first of all, we start with the vertical asymptote, which we equate the denominator to 0. Okay, so x is equal to 3 is the vertical asymptote. And also here we are observing that we have an oblique asymptote. And how is it that we have an oblique asymptote? Is because of the degree of the numerator, which is 1 greater than the degree of the denominator. The degree of the numerator is 2, the degree of the denominator is 1. So because of that, it means we have an oblique asymptote. And to find it, we have to divide. So we are going to say x minus 3, and we divide it into x squared. Let's just write it as x squared plus 0, x plus 0. So x into x squared is x. So x and x times this will give us x squared minus 3x, right?
Yep.
And we subtract. So we get here 3x plus 0. Then x into 3x, that's 3. And 3 times this whole thing will give us 3x minus 9, and then we subtract and we get the remainder as 9. So we don't care about that much, but what we want is the quotient, which gives us now the equation of the oblique asymptote. So oblique asymptote is therefore y is equal to x plus 3. All right.
Okay.
I'm sure that's what you got.
Yep.
All right, that's fine. Let's move on. Going on to part B, it says, show that there is no point on C for which y ranges between 0 and 12. All right. So we take the equation, all right? The equation is y is equal to x squared over x minus 3. So we're going to multiply both sides by x minus 3 so that we can come up with something that is more like quadratic, right? So we have y of x minus 3 is equal to x squared, which is xy minus 3y is equal to x squared after expanding the brackets. And if we bring everything to one side, we'll be having something like x squared, right? And that's going to be
Minus xy.
minus xy plus 3y equal to 0. So this is a quadratic equation in x, all right? And we can say that a is the coefficient of x squared, that's 1. B is going to be minus y, and C is going to be 3y, all right? So if there are no points on C, okay, for no points on C, it means that b squared minus 4ac should be less than 0. So basically, we'll be saying here, b squared minus 4ac, b squared minus 4ac is minus y minus 4 of 1 of 3y is less than 0. So that's like y squared minus 12y is less than 0. So it's y of y minus 12 is less than 0. So the critical values are y is equal to 0 or y is equal to 12 here. And if we consider this, this is 0, okay, because the shape of the graph is going to be a U-shaped parabola. All right, maybe like this. For this particular quadratic, with this being 0 and this being 12. So less than 0 means negative. So it's negative for values of y between 0 and 12. All right, so I'll say here, therefore, the solution is 0 less than y less than 12 because it is negative for these values here. Okay, that's where it is. The graph is below the y-axis. So that's how we show it, okay? They had said show that there's no point on C for which that, and that's how we show it. Is this the same way you did?
Yeah, I think
Okay,
so.
good. So good so far. Let's move on to part C. Part C says sketch C. So to make a sketch of C, we're going to have the axis, okay, X and Y axis here. So X here, Y, and the origin. Let's put in the asymptotes. We have X equals to 3, right? So X equals to 3, say, is this line here. Okay, so this is it, okay, at 3 here. Then the other one is an oblique asymptote. Y is equal to X plus 3. All right. So it is going to go this way. Y is equal to X plus 3. It intercepts the Y axis at 3 here. All right. And the X axis at some other point, which is again is a 3. Actually minus 3. All right. Okay. So this is a type of graph which is undefined for some certain values of y. So what that points to us is that the graph should be like this. All right. And then does it intercept the axis? We have to know. Okay, let's check. Um, the graph is y is equal to x squared over x minus 3. All right, so to determine whether it intercepts, we say when x is equal to 0, we get that y is equal to 0. So it passes through the origin. So basically, we expect the graph to be like this. Okay, so the graph is like this. All right. Is this the same type of graph you came up with?
Yep. Mine is drawn a bit more ugly though.
Okay. All right. Let's go on to part D. They say on D part I, sketch the graphs of y is equal to mod of x squared over x minus 3 and y is equal to mod x minus 3 on a single diagram stating the coordinates of the intersections with the axes. All right, stating the coordinates of the intersections with the axes. Right, so what is this? Let's start with this graph. Y is equal to x squared, all right, over x minus 3 under modulus. So we already have the original graph for y is equal to x squared over x minus 3. All right, so we're going to copy that because we're just going to do a modification of this graph. So here it is. And the part of the graph that is below the axis, we're going to reflect it below the x-axis. We're going to reflect it in the x-axis to get the modulus graph. So we will have something like this. All right. And then it goes like this. This part of the graph will remain. This line segment will remain. It will just remain. Okay. So that's the graph. So we're going to remove the part that is below because we no longer need it. It has been reflected already, so we don't need it anymore. All right. Think this is fine. So this is still O. This is still minus 3. This is still 3. Okay. But they say on the same axis, we should draw the other graph, which is the graph y is equal to mod of x minus 3. All right. So we start with the line y is equal to x minus 3. Okay. All right. So let me extend this line a little bit. So we go to minus 3 and we draw the line. It has to pass through here. So it goes like this. So that's the line y is equal to x plus 3. All right. And we are also going to need the graph of y is equal to, actually, when we have this graph here, it's intercepting at minus 3. Since it's mod x, it's a graph of y is equal to f of mod of x, basically. So we eliminate the part of the graph that is in the negative y and the negative x-axis, rather, and we reflect the part, this part, in the y-axis. So we have something like this
Yep.
going.
Okay.
So that's the graph. Okay. So we're saying that this is the, okay, let me just remove this. So here we have the graph y is equal to mod x minus 3. All right. And the one in green is y is equal to mod of x squared over x minus 3. Since the question is saying stating the coordinates of the intersections with the axis, we are going to, for minus 3 here, that's 0, minus 3. I'll write that down as coordinates, all right? The 3 is actually 3, 0. The minus 3 is minus 3, 0. Like this. I think it's better now. All right, let's move on. So on part 2, they say, use your sketch to find the set of values of C for which the modulus graph mod of x squared over x minus 3 is less than or equal to mod x plus C has no solution. Okay. All right. So you need to understand that when you have less than or equal to, all right, less than or equal to, or just less, it means vertically below. Okay. So when this inequality goes, or when this question says, find the values of set of values of C for which the modulus graph is less than or equal to, it means where it is vertically below or equal to, okay? So vertically below the graph, the other graph, okay, of mod x plus C, has no solution. So in other words, we're looking, the other way we can put this is to say we're looking for the set of values of C for which the modulus graph is above, okay, because less than or equal to has no solution. So in other words, we're looking for greater than. In other words, that's what we're looking for. So the set of values of C for which this graph, the modulus graph, okay, this whole graph and this line segment is vertically above or will continue to be above that of mod x plus C. All right. So this is going to happen for values of C that are less than or equal to minus 3. All right. So in other words, if you look at it in terms of translations, we mean the graph of mod x minus C, which is this graph here represented by these two line segments, which are from minus 3 going downwards. That's where the graph of modulus will always be vertically above that of mod x minus C. Because if we go up, then there's going to be intersections between the graphs and it will not satisfy the condition given. So the correct answer should just be values of C that are less than or equal to minus 3. So that's how we answer this question.